Howdy. We're going to do a little extra with higher derivatives. This is called Leibniz Rule. And remember that the product rule had told us how to do one derivative of a product. It was f prime g plus f g prime. So it's natural to ask, what if you had two derivatives? Well, the way you do two derivatives is to first do one derivative, and then after you do that, do another derivative. So, product rule, f prime g plus f g prime. We still owe another derivative. So if we do that, on the first term it would be another derivative on f, so f double prime g, plus, now a derivative, leave the first term alone, f prime, and take a derivative of the second. And then for the second term, a derivative on f, leave the second alone, and then leave the first alone, and another derivative on the second term. So that's g double prime. So if we gather terms here, we've got some repeats. So we end up with f double prime g plus 2 f prime g prime plus f g double prime. Okay, so notice how the derivatives start all two of them on f, none on g, and they slowly work their way towards g. So only now one on f and g gets one, and then none on f and g gets both of them. You can do this for 3 derivatives, 4 derivatives, or whatever. I'll just tell you the answer here. No derivatives is that. If you've got one derivative, the product rule was f prime g plus f g prime. 2 derivatives was f double prime g plus 2 f prime g prime plus f g double prime. So a new one that we didn't do is this, f g triple prime. It works out to be 3 derivatives on f plus 3f double prime g plus 3f 1 prime g2 prime plus f g triple prime. And then this pattern on how the derivatives behaves continues. So you notice here it's 3 derivatives on f, then 2, then 1, then none, and meanwhile g is going up accordingly. So the thing we don't understand is all these coefficients that we've got. So we have a 1 up here in front of fg, and then another 1, 1, and a 1, 2, 1, and a 1, 3, 3, 1. Let me write just those coefficients. Turns out if you do this, the coefficients you get look like this. And so forth. And this is called Pascal's triangle. And the rule is to figure out the next row, you add the 2 people above it. So 3 plus 3 tells you it's a 6 there. If you want to figure out this row, you look at the 2 people above it and add them. 6 plus 4 is 10. Pascal's triangle, it turns out, if you look at sort of the nth row and kth column, is governed by this number here, called a binomial coefficient. And if you'll remember, it's n factorial over k factorial n minus k factorial. They're always integers, and they match up with Pascal's triangle. Don't forget, there's a convention that 0 factorial is defined to be 1. Anyway, we can now give Leibniz's rule for doing higher order derivatives. It's this, that if you want to do the nth derivative of a product, you use these binomial coefficients and initially give f all the derivatives and g none. And then you work your way up this binomial tree here, lowering the derivatives on f and increasing them on g. You keep doing this till you're at the end. It'll be n choose n, no derivatives on f, and all the derivatives on n. Anyway, it's not something you have to memorize, but it's pretty cool. All right, see ya.